Okay, and we now have the circle. So write down the center and the radius of the circle. So anything to do with the circle, we should already be looking on page 19 of the log tables. We've been given the equation. So what I'd really do is just underneath, I would write down my formula for the equation of any circle. So that tells me that 2g is equal to minus 10 and that 2f is equal to minus 4. So g is minus 5 and f is minus 2. But of course, from our log tables, we can see that the center of our circle is minus g minus f. So because of the minus, that changes to a positive 5, and this changes to a positive 2. So our center is in fact 5 over 2. Our radius is supposed to be g squared plus f squared minus c. So if our g is minus 5, we're going to square that. Our f is minus 2, we're going to square that. Minus c in this case is k. So we end up with 25 plus 4 minus k. So we end up with the root of 29 minus k to represent our area. In the next part, it says the midpoint of the chord of C is 4, 1. So the middle point is 4, 1. And its length and its total length is 4 root 2. Find the radius length of C. Now, we learned something very important in class, and that is when the radius comes down onto a chord, it bisects it and it meets it at 90 degrees. So those two facts are really important. Because it bisects, we immediately know that 1/2, so for example, this bit, is half of the length of the chord. So instead of 2 root 2, the green bit, instead of 4 root 2, the green bit is 2 root 2. Now, we know the center from the start of the question is 5, 2. And I know that the point right there, the midpoint, and it's definitely the midpoint because remember it bisects. So if I can get the distance from 5, 2 to 4, 1, well, then I've also then got the distance from here to here, the pink part. So when I put that into my distance formula, I end up getting, well, let's label it. So x1, y1, x2, y2, and I do the root of x2 minus x1 to be squared plus y2 minus y1 to be squared. You can actually put them in any order, so it doesn't really matter there. So what's that? That is minus 1 squared, which is 1 and 1. So it's actually the root of 2. It's the root of 2. So the pink bit is the root of 2. Now the actual radius is this bit here. So we'll just call that R. Now, the second thing is that when we drop a radius onto a chord, it meets it at 90 degrees. So therefore, we can use Pythagoras in that triangle. So Pythagoras tells us the hypotenuse squared, so the R is our hypotenuse, is equal to the other two sides squared and added together. So what I'm basically doing is I'm squaring this to become 4 times 2. I'm squaring the 2 and I'm squaring the root of 2. And a square and a square root, of course, cancel each other out. So I end up getting my radius squared to be 8 plus 2. So my radius squared is 10. So my radius is root 10. Then I have to find the value of k. So from up here, the radius is the root of 29 minus k. I now know the radius is root 10. So I can equate those together. I can drop the roots because I'm technically I'm squaring both sides. So they're both gone, and that's 10. So 29 minus 10 is equal to k, so 19. So I actually discover there that k is 19. And that's that part done.